Facts are not science, as the dictionary is not literature. Martin H. Fisher. Chapter 1. Chemical Reactions and Equations. Consider the following situations of daily life and think what happens when milk is left at room temperature during summers. An iron tawa, pan, nail is left exposed to humid atmosphere. Grapes get fermented. Food is cooked. Food gets digested in our body. We respire. In all the above situations, the nature and the identity of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Activity 1.1. Caution: this activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon about 3 to 4 cm long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as shown in Fig. 1.1. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? Figure 1.1. Burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. Rationalize 2023-24. You must have observed that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Activity 1.2. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe? Activity 1.3. Take a fusing granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this. Fig. 1.2. Caution: handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observations helps us to determine whether a chemical reaction has taken place. Figure 1.2. Formation of hydrogen gas by the action of dilute sulfuric acid on zinc. Change in state. Change in color. Evolution of a gas. Change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representation in this chapter. 1.1. Chemic. Al-EQUA. 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 TIONS. Activity 1.1 can be described as: when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen, right pointing arrow, magnesium oxide. Reactants. 1.1. Product. The substances that undergo chemical change in the reaction. 1.1. Magnesium and oxygen are the reactants. The new substance is magnesium oxide, formed during the reaction, as a product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left-hand side, LHS, with a plus sign, plus, between them. Similarly, products are written on the right-hand side, RHS, with a plus sign, plus, between them. The arrowhead points towards the products and shows the direction of the reaction. Science. 2. Rationalize 2023-24. 1.1.1. Writing a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2, right pointing arrow, MgO. 1.2. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. 1.1.2 Balanced chemical equations. Recall the law of conservation of mass that you studied in class 9. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical EQ 1.2 balanced? Let us learn about balancing a chemical equation step by step. The word equation for activity 1, the third of may be represented as zinc plus sulfuric acid right pointing arrow zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation. Zinc plus H2SO4 right pointing arrow ZnSO4 plus H2. 1.3. Let us examine the number of atoms of different elements on both sides of the arrow. Element zinc H S O. Number of atoms in reactants LHS 1, 2. Number of atoms in products RHS 1, 2, 1, 4, 1, 4. As the number of atoms of each element is the same on both sides of the arrow, EQ 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation Fe plus H2O right pointing arrow Fe3O4 plus H2. 1.4. Chemical reactions and equations 3. Rationalize 2023-24. Step I. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Fe plus H2O right pointing arrow Fe3O4 plus H2. 1.5. Step 2. List the number of atoms of different elements present in the unbalanced equation. 1.5. Element Fe H O. Number of atoms in reactants LHS 1. Number of atoms in products RHS 3, 2, 1, 2, 4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms of oxygen in reactants, in products, I initial, E to balance, 1 in H2O, 4 in Fe3O4, 1 times 4, 4. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compounds or elements involved in the reactions. For example, to balance oxygen atoms we can put coefficient 4 as 4H2O and not H2O4 or H2O4. Now the partly balanced equation becomes
في زائد 4H2O سهم متجه لليمين في 3O4 زائد H2.
1.6. Partly balanced equation. Step IV. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of H atoms, make the number of molecules of hydrogen is 4 on the RHS. Atoms of hydrogen in reactants, in products, I initial, E to balance, 8 in 4H2O. 8. The equation would be
في زائد 4H2O سهم المتجه لليمين في 3O4 زائد 4H2.
2 in H2. 2 times 4. 1.7. Partly balanced equation. Science. 4. Rationalize 2023-24. Step V. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is, iron. Atoms of iron in reactants, in products. I initial, E to balance. 1 in Fe. 1 times 3. 3 in Fe 3O4. 3. To equalize Fe, we take 3 atoms of Fe on the LHS.
3 في زائد 4 H2O سهم متجه لليمين في 3O 4 زائد 4 H2.
1.8. Step V. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation.
3 في زائد 4 H2O سهم متجه لليمين في 3O 4 زائد 4 H2.
1.9. Balanced equation. The numbers of atoms of elements on both sides of EQ 1.9 are equal. This equation is now balanced. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above balanced EQ. 1.9. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous and solid states of reactants and products are represented by the notations G, L, Ag, and S respectively. The word aqueous, Ag, is written if the reactant or product is present as a solution in water. The balanced EQ 1.9 becomes
3 في S زائد 4 H2O G سهم متجه لليمين في 3O 4 S زائد 4 H2 G.
1.10. Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions, such as temperature, pressure, catalyst, etc., for the reaction are indicated above and or below the arrow in the equation. For example, COG plus 2HG 2 6CO Ag 12HOL 2 plus 2 1.11 340 atmospheres CHOL. Right pointing arrow. 3. Sunlight chlorophyll. Right pointing arrow. CHO Ag 6O 6126 glucose plus 22 plus Ag 6HOL 2 1.12. Using these steps, can you balance EQ 1.2 given in the text earlier? Chemical reactions and equations 5. Rationalize 2023-24. Questions 1, 2, 3. Why should a magnesium ribbon be cleaned before burning in air? Write the balanced equation for the following chemical reactions. I. Hydrogen plus chlorine. Right pointing arrow. Hydrogen chloride. E. Barium chloride plus aluminium sulfate. Right pointing arrow. Barium sulfate plus aluminium chloride. E. Sodium plus water. Right pointing arrow. Sodium hydroxide plus hydrogen. Write a balanced chemical equation with state symbols for the following reactions. I. Solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate in the solution of sodium chloride. E. Sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride solution in water.